I'm very honest here. 5 years ago, my understanding of a digital twin was at a very shallow level. On the other hand, now if I compare back to 5 years, I can say that I have a little bit more understanding of it, right? So now the first thing which we have to, these can be prototypes. For example, a globe, that is a prototype, a small scale physical model or a prototype of the earth, right? So now what we try to do is, there is a physical system, right? So how you can understand a physical system? Either you perform experiments, for example, in fluid mechanics or in solid mechanics, in mechanical engineering, we are doing a lot of experiments. Universal testing machine is there, fatigue testing machine is there, right? So we are performing some physical experiments, right? Which is generally at a lab scale level. Then there comes another thing which is called as an expert knowledge. So what is an expert knowledge? Let's say I can say that, okay, I have worked for 10 years in industry and I have some experience, which is a field experience. So I will try to couple my knowledge from the field with the lab data, and then we are observing the entire world, right? So this, what you see over the left, this was a general practice in science and engineering, which we guys were following. But now what has happened is that we are trying to construct these virtual models, right? These virtual models, again, those of you who are doing finite element modeling or who are well versed with computational fluid dynamics, what we are trying to do is we are trying to create a digital model, a 3D model using, let's say, software such as AutoCAD, Inventor, SolidWorks, right? And once we have physically, right? Once we have physically emulated all of the aspects of a physical model, then we are performing, what are we trying to do? We are performing some simulations. Example, again, CFD or FEM, right? Again, this is one way. But over the past, let's say 10 years, what has happened? These data-driven models, right? So they have come into the picture. So you have a physical system, you have a model, and then in order to validate your model, you are trying to compare both of these knowledge or information, and then you are improving either these models or the theories that are generated. So this is a generic framework which can be applied to any system that we are studying, right? So now I'll go back to this hype versus reality. So as I mentioned that there is, all of these are buzzwords, right? So I believe most of us have heard about artificial intelligence. It's everywhere. We are using it, right? ChatGPT is one of the examples which we can say is a very disruptive kind of the use of a generic artificial intelligence or a general artificial intelligence. Then we say IoT, we are using our telephones, and you see we have a 5G network, we have something called as a cloud computing. Then we have, for our colleagues who are working in the civil department, they are using a lot of these BIMs, which is building information modeling. We have cyber physical systems, industry 4.0, industry 5.0, right? So all of these terms are being used widely. Now what this consulting firm Gartner has done is, so what they try to do is they have created a, let's say, a plot like this. On the x-axis you have a time, and on y you have an expectation, right? And then they have divided, you can see there are 5, let's say, partitions. So there is the first partition where we say that a new technology is born. You know, people are very optimistic about it. Let's say ChatGPT, for example, right? So now people are very optimistic about it. We are creating our itineraries. We are asking some very generic questions, you know, day-to-day life questions. Students are using it to make their, and again, most of what I'm saying, it is based upon my experience in my university and in the European context. That is what I'm, so it might differ a little bit from the Indian context because I'm not very well aware of it. But let's say in Europe, people are using ChatGPT, or students are using ChatGPT in order to create their assignments, etc. Right? So for now, this is an aha moment, right? This is the thing, right? And then when you are so much, you know, when you get accustomed to these kind of technologies, then your expectation starts to rise, right? So let's say I can say that, okay, I use ChatGPT in order to create an assignment or an exam for my students, right? I gave the entire book and I said, okay, make 100 multiple choice questions, right? And then my expectation is that it should give me the foolproof questions, right? But you see that all of these large language models, they have a tendency to hallucinate. So I am expecting that it should give me a product or It should elicit out these questions which are having a very high degree of pedagogical content. But then my expectations over the time, they tend to decrease because it is not matching my expectations, right? So then you are caught into the third phase, which is called as a trough of disillusionment, right? But then what happened, as you know that, okay, initially there was a problem of hallucination, then different kind of supportive, let's say, models are coming or techniques are coming. For example, rags, right? Retrieval augmented generation, that came into the picture, where these hallucinations were reduced quite at a very rapid pace, right? And now we say that there is a concept of this agentic AI, right? Now you have multiple agents. So now again, these technologies such as ChatGPT, they are over here, slope of enlightenment, right? And then finally, plateau of productivity, where people are using at all of the scales, starting from horizontal to verticals, right? So now you can see, I just gave you a simple example, which means any kind of a technology that is coming to the picture, what Gartner will do is that it will create or it will map all of these technologies over here, right? So we don't have to do it. This is a consulting firm which is doing it, and it is a very in industries, people are easily adopting it. So now with this background, as you can see, you have this plot. So in 2000, and I think it was 17, so you can see that different kind of technologies were plotted. For example, virtual reality is here, augmented reality is here, but digital twin in 2017, they were at the first phase. So if I go back, what is the first phase? It was an aha moment that, wow, let's say ChatGPT in 2023, January, February, people were talking about it because its date of inception was in November 2022. So in the similar fashion, digital twins in 2017, they were in the first category. And then what happened in 2018, they were over here, right? At the peak, what is this? This is the point of expectations. It is expected that this is a panacea for all of the cures, right? So it means that they can do everything for you. So that was an expectation in 2018. And what are the other technologies? Here you can see deep learning or deep neural nets, right? Mixed reality, augmented reality, right? So it was still here. And if you don't see virtual reality over here, it means that it has already passed this. People are adopting it. And we know that virtual reality is being adopted at a very wide scale. So now this was the scenario for the digital twin when I use a framework or this plot from the Gartner, right? So it means that in 2018, they were at the highest of the, so this is called as the highest hype, right? They were at the highest hype. Now I'll go back and so my aim for today is that firstly, I will, as I mentioned, I'll little bit confuse you. By confusion, I mean, I'm talking about, like, as I mentioned, that what is the difference between digital twin and an Internet of Things? How is digital twin different from a cyber physical system? I have already been using simulations. So what is the difference between the CFD simulation and a digital twin, right? I have heard about big data. How does it, let's say, retrofit with a digital twin? Or what is the use of AI in digital twin, right? So all of these questions are here to confuse you. And later on, my aim is that I'll try to unconfuse you, right? I'll talk a little bit more about digital twin so that you can easily segregate these concepts. And again, it is, I cannot promise that within the next 1 hour, you will be well versed with this. But again, it could be, a small light in the dark tunnel. So now, this is a word cloud for the definitions of digital twin in literature, right? So here you can see you have digital, you have virtual, you have physical, product, real, object, all of this, probabilistic. So how did I create this? I took a bunch of papers, right? Scientific literature papers for over 10 years. And then again, using these rags, I said that, okay, I want to train you and then create a word cloud for me. So this word cloud is a, let's say, a representation of how people are defining or what are the other terms that are being used in context to the digital twin, right? So now the first question, that what is a digital twin, right? So before we define this, and this definition, as I will talk about it, it comes from the researchers. There's a digital twin lab over there. So they have created this definition, right? And I find this as a most comprehensive and a very informative definitions. But as I mentioned, there are more than 50 definitions of digital twin. So now, before I explain what is digital twin, I want to part these two words separately. So firstly, I'll explain what is digital, and the second is what are we twinning, right? So in order to explain what is digital, let's try to understand how, how photographs were being taken. So let's say 15 years ago, if you were going out for a family picnic or you were going out with a friend, when the use of mobile phones was not that very common. So here you can see there were these cameras, which commonly known as DSLRs, right? Or, let's say a very common, when you go to these marriages in Himachal, right? And if you have a photographer, so what they used to do is they had these something called as an analog camera. So they used to click pictures, and later on they used to take these reels and produce the pictures for you. On the other hand, now the concept of photography has changed, right? Now you have mobile phones. Every phone is having, let's say, camera starting from 5 MP to say 15 megapixels, right? So now understand the difference between analog and digital. A very simple understanding is something which can easily be transmitted from point A to point B electronically is digital, right? You can create replicas of it. If I take a photo from my camera, I can easily send it to say thousands of people within 1 minute, right? If I have a good connectivity using WhatsApp, right? So your data is being transmuted to these zeros and one. At the end, digital data is zeros and one, right? And then it is transmitted, firstly transmuted to 0 and 1, then transmitted, and then finally converted back to an image. So that is a digital data. But I cannot do the same with analog data, right? The process of generating an image from these reels, it is a chemical process, right? And I cannot send it electronically, right? So that people can argue that, okay, you can take a photo, you can take, using your iPhone, you can take a photo of a physical print, which has been generated to this. But again, you are creating a digital out of an analog data, right? So with this example, I want to create this understanding of, in a very layman term, that what is analog data and what is digital data, right? So now we will focus on digital, right? So the digital is anything which can be easily transmitted from point A to point B electronically, right? And it's at the end zeros and one. So now here you can see this is a 3D model, right? A 3D model of wind turbine. I can easily send it, as I mentioned, via email to anyone, right? And again, I can make changes to it, right? So this is a 3D model, simple thing, nothing difficult. So I can use this 3D model for plethora of activities. What can I do? I can do a lot of simulations, and that is where most of the colleagues who are working with CFD or FEM, right? We are using this. And in engineering, we have been doing that, right? So I'll show you a timeline in the next slide. So here you can see we are, again, blade aerodynamics, a classic problem for CFD, right? We are using these thermal cooling. So all of this, it can easily be, let's say one of the softwares is of the Dassault systems, where you can easily do all of this, right? So a 3D model is used for generating simulation data, right? To understanding different scenarios. But again, this is not digital twin, right? Then what you can do is, so here, what you are seeing is, this is a, if I take it, so this is a Simulink model. So now notice one thing, when you are using 3D model generated in, let's say, AutoCAD, and you're using it for simulations. So here the physical replica of the 3D model the virtual replica of a 3D model should be identical to the physical system, right? So here you are replicating the geometry. But there is another way of creating simulations, which is called as a model-based engineering. So here, what we are seeing is for the same wind turbine, we have created a model which is not a physical replica, because here you can see here, this is just a representation of this, but it is a functional model, a fully functional model. All of the control systems or electrical systems, hydraulic systems, they have been easily, let's say, modeled into this. So this is a Simulink model, which falls into the category of model-based engineering. But again, this is also not a digital twin, right? So here you can see, and this is something which the engineering community has been doing from the past 50 years. So nothing new in that. So now, if I go back, as I mentioned, that I want to create this difference between a simulation and a digital twin. What is a simulation? What is a digital twin, right? So firstly, I'll explain what simulation is. So if we delve, say, 60 years back, so simulations were used. And one very important understanding for the entire engineering community is that all of these revolutions in engineering, they have been, let's say, pioneered by the aeronautics and aerospace, right? And the primary reason is because weight is a very, very important parameter. Let's say when I was designing pipelines for oil and gas, right? So in generally, most of these structural elements, what we try to do is we say that, okay, it has a load bearing capacity of, say, 100 bars, right? Let's say. And then what you can try to do is, or let's say the pressure, right? So you design your pipelines for pressure, right? So internal pressure can be 100 bar. So then what we try to do is we take this codes or industry standards. In our case, it was DNV, the Nos Veritas. So what they try to do is they say, oh, whatever you have calculated, right, have a design factor of 2.5, increase the thickness, and that is good, right? Because again, weight is not an important parameter. On the other hand, you want to, so we over design, right? But in aeronautics and aerospace, that is not a possibility, right? Your aircraft has to be as, it should have the as much high strength as it can have, but it should be as light as possible. So that is why all of these simulations, or let's say your non-destructive testing, all of these, the pioneering was done with these two particular industries, right? So they were the first ones who were actually using a lot of simulation softwares, right? So the usage wide adoption of simulation started in 1970s. And again, it has to do a lot with how our colleagues in, or how the R&D was being done in this computer and IT, right? Because you cannot create a simulation without advancement in the computer science, right? So then before this, everything was experiments. So in 1970s, this was started, right? And then by 2000s, we were talking about computer aided design, right? Computer aided manufacturing. So now you see, we have something called as fusion, where you can actually, you can couple your CNC milling along with the software. It will actually tell you how the pattern will be, or how you should do the milling. Additive manufacturing came into the picture, right? So all of this was an, let's say, little bit more functionalities were added to the simulation softwares with these. And then from 2010, so let's say just 15 years ago, this concept of digital twin came into the picture, right? So rather than telling you what that is, now I'll delve deeper into digital twin, that how this concept, or where and when this term was coined.